Hi, this is Sunil Manji, Senior Principal Solution Architect at Elastic. Today I'll be demoing an application that I built called Elastic Game Guardian. It's mostly to showcase the art of the possible of using Elastic Vector Search and Generative AI, or Azure OpenAI, for example, here. Just to provide a little context for those that may be watching, Elastic has long been known for speed, scale, and relevance. Those are known quantities. And with Elastic, for example, I store game titles, right? My kids like to play games. I have three of them. And if they ask me a question about, hey, Dad, I want to find a game with dance, or I want to find a game with combat, I would have to be precise in asking the question or searching for, let's say, Call of Duty. Now, in Elastic, historically, to relate combat to a specific game title or to a document, you can create synonyms. But with vector search, you no longer have to do that. With vector search, you could be incredibly imprecise in your search and get high relevant precision results. And that's exactly it. I could ask for combat and it would return games like Call of Duty. And with generative AI or Azure OpenAI, I can leverage that to provide additional context about the games. And that's exactly this use case. My kids often ask me, "Hey, Dad, I want to find a game with combat or dance," or they say, "Dad, I want to play with Darth Vader." And I can now use Elastic Vector Search to perform that search. However, I also want to know if it's appropriate for my child's age. And there may be games that are appropriate for my oldest, but not for the mid or the youngest. Some of them may not be appropriate for all three. Some may be appropriate for all of them. So I'm using this application, basically Elastic Vector Search and Azure OpenAI integration, to determine the appropriateness of the results or the games that are returned from Elastic. So let's get to it. So, for example, my child that is 10 years of age will ask the question, "Dad, I want to play a game with Darth Vader." So here I'll type in Darth Vader and I'll do a search. What's happening here is uh, I'm performing a vector search against Elastic, which is incredibly fast. And then I take that result, those game results, and I call Azure OpenAI for each game to determine the appropriateness by the age of the child. And as you can see, we have some results. So the first result is Star Wars Battlefront, saying nope, it's not appropriate for the age of 10. Lego Star Wars The Force Awakens, that's yes. So as you can see, the games, the titles are stored in Elastic, but I'm using the guidance field was really enriched by Azure OpenAI or Generative AI to tell me that whether the game is appropriate for my child. So let's try one more example. My girls love games with dancing, or they just love dancing in general and singing. So my 7-year-old said, "Hey, Dad, I want a game, something to do with dance." So I don't have to be precise. I can be imprecise here in my ask, and from Elastic Vector Search, and then I want to go and forward the results to Azure OpenAI to tell me whether the games returned by Elastic Vector Search are appropriate for my 7-year-old. And so the results have returned. I can tell you that the results from Elastic Vector Search are immediate, milliseconds. It's the round trip of calling Azure OpenAI and some of the rate throttling. That's the longest pole in the tent in terms of latency. But when it comes to Elastic Vector Search, it is immediate results. So you can see here that the game theme for dance for my 7-year-old, Just Dance is not appropriate. Just Dance 2020 is not, and you can see. So it's unfortunate. I'll have to tell my girls, sorry, we don't have games right now on Xbox or whatever system that are appropriate for your age. So what did we do here? We leverage Elastic's vector search to perform search results, or to execute search with imprecise ask, but with high relevancy results, with high precision results. And then integrating it with a large language model, for example, Azure OpenAI, to enrich the data set. So this can be used by many organizations that store their private data in Elastic and want to add additional context using large language models. Thanks for watching. Hope you enjoyed that.